Welcome everyone. This is Laura Podolsky with the National Center for Sustainable Transportation. We're excited you joined us for today's webinar, Reducing Cost and Emissions with Eco-Driving for Transit Vehicles. This webinar is brought to you by the National Center for Sustainable Transportation hosted at the UC Davis campus. The National Center is one of 5 centers designated by US DOT as a part of their University Transportation Centers program. Our mission is to advance a more sustainable transportation system through cutting-edge research, direct policy engagement, and education of our future leaders. Our consortium is being led by the Institute of Transportation Studies at UC Davis in partnership with University of California at Riverside, University of Southern California, California State University at Long Beach, University of Vermont, and Georgia Tech. Today's webinar is part of the rollout of a new research from the National Center, co-authored by our speaker today. The final report is posted on the Center's webpage and can be found by using the link provided in the chat box. We will also be sending the link to the paper in the follow-up email after this webinar. So for today, we'll spend the first half of our webinar hearing from our speaker, with the second half dedicated to Q&A with all of you, so we hope that you came with questions. We are particularly interested in hearing from all of you regarding research and our knowledge gaps on this issue and what you feel are important research directions on this topic. You can share your thoughts via the chat box, again, that's located in the left lower hand side of your screen, and or in our post-webinar evaluation that we'll be sending out to all of you. As you can probably tell, everyone is on mute, so if there are any obnoxious, distracting noises on today's webinar, then you can blame it on us. We do encourage questions, though, so if you do have a question for our speaker or any of our guest respondents today, then again, please type those into the chat box located in the lower left hand of your screen. You can also use this chat box to let us know if you're running into any technical issues, and we'll do our best to help you. Finally, we will be recording this webinar and posting it onto our event page for later viewing, and we will provide the links to locate the webinar recording, as well as the slides in our follow-up email to everyone. So be on the lookout in your inbox for an email from us. So without further ado, I'm pleased to introduce our speaker today and our distinguished special guest respondents. Dr. Ann Hsu currently serves as the Georgia Tech Operations Director of the National Center for Sustainable Transportation. Dr. Hsu's research focuses on the application of energy and air quality models to large-scale disaggregate data. Dr. Hsu is the primary developer of the Federal Transit Administration's Fuel and Emissions Calculator in collaboration with the Oak Ridge National Laboratory. This calculator assesses the economic and environmental impacts of purchase and operations decisions of alternative fuel and drivetrain transit systems on life cycle greenhouse gas and criteria pollutant emissions. We are fortunate to have 2 special guest speakers today, Rob Goodwin with the Georgia Regional Transportation Authority and Art Gazzetti with the American Public Transportation Association. Rob Goodwin is the Chief Performance Officer at the Georgia Regional Transportation Authority. He operates the Express Commuter Bus Service, or I shouldn't say he does, the General Regional Transportation Authority operates the Express Commuter Bus Service in Metro Atlanta, carrying more than 2 million passengers annually. Among other duties, Rob is responsible for developing and monitoring the annual operating budget for Express. Rob has a background in transportation and air quality, planning, and research. Art Gazzetti is a 37-year professional in public transportation at the local, state, and national levels. Serves as the Vice President of Policy for the American Public Transportation Association, the trade group for the public transportation industry. Among other things, Mr. Gazzetti is responsible for APTA's extensive policy development and research agenda, and for advancing policies favorable to public transportation with Congress, the administration, state and local governments, with grassroots and stakeholder organizations, and with public policy think tanks. So without further ado, I would like to have Dr. Ann Hsu start her presentation. Thank you so much.
Hi everyone, this is Ann Hsu. Thank you so much for joining our webinar today. Before I start, I would like to acknowledge my co-authors. They are graduate research assistants Ann Lee and Haobing Liu, and senior technical advisors Mike Rogers and Randy Gesser. And I apologize for my voice. I do have a cough, and I'll try very hard not to cough during the presentation. So here's what I'm going to talk about today. After a brief introduction, I'm going to talk about what exactly eco-driving means in this study and in general. And I'll present a case study using 2 transit agencies in Atlanta, and GRTA is one of them. That's where Rob is from. And then I'll come to conclusions and talk about ongoing and future efforts. As far as introduction, we all know that transit agencies are always seeking opportunities to conserve fuel and in order to lower operating costs.
Hello, Anne. This is Laura. We heard you cough, but I'm wondering if you had maybe pressed your mute. We cannot hear you.
I'm back.
Okay, great.
Yeah, sorry. Operating improvement is one of the options, and the alternative fuel buses is another. And in this study, we looked at eco-driving as one of the operating improvements, and CNG as one of the alternative fuel bus strategies. We look at MARTA and GRTA, the 2 transit agencies, for their fuel savings and emissions reduction. To give you a preview, to give you a preview of the key findings, eco-driving conserves fuel, and we found that eco-driving can reduce fuel consumption by 5% in local service and 7% in express service. Eco-driving works for CNG fleets. It also saves cost. And so here we look at what exactly we mean when we say eco-driving. Eco-driving is a feasible strategy that is well known for all kinds of eco-types. There are many techniques for eco-driving, including anticipate the traffic, maintain a steady speed, limit engine loads, limit idling, so on and so forth. In this study, we focus on 4 aspects: maintain a steady speed, limit engine loads, limit high speed, and avoid hard accelerations. I do want to point out that limit idling is an important aspect of eco-driving as well, but our study presented today is only focusing on the on-road aspect of it. We did produce a research on school buses a couple of years ago looking exclusively on idling, and we did find significant savings from anti-idle as well. So here is an overview of how we evaluated eco-driving in our study. We simulated eco-driving behavior using a fairly straightforward algorithm. This slide shows how this algorithm works. So we take a vehicle speed time trace, also known as a duty cycle. And we modify this duty cycle as shown in blue color on the slide using 3 stages. And the resulting eco-cycle is shown in the red dotted lines. So on first glance, you'll notice that we trimmed a lot of this hard acceleration right here to smooth it out. So to have a closer look, you'll see that at the very beginning, the first stage is what we call maintaining status quo. This is when the vehicle is operating under low power conditions. So we keep the existing speed and acceleration. Once the vehicle hits a threshold, as shown right here, we start to limit its power by limiting its acceleration. Thus you see this smooth line until, and it keeps this way, and we call this smoothing state, until it reaches the original speed that the vehicle was supposed to go. And then we start to conserve distance, and this is the third stage called conservation of distance. So basically, because for all this time during smoothing, the vehicle is going slower than the original cycle, and it has to maintain this speed going a little bit further to catch up, so to speak. And then we go back to maintaining status quo, going back to stage 1. So how do we decide how much of this trimming we should do? And here I explain on the next slide. So this is the nerdy part of today's presentation. I promise you it'll be the only, the nerdiest part. After this slide, it gets better. We avoid high power operations using a concept used in the EPA's MOVES model called the scale tractive power. It basically is a surrogate to the engine load. And on the slide on the left, you'll see a chart that's the fuel consumption rate in moves by speed and by STP bins. And you'll notice that it's grouped into 3 speed categories: low speed, medium speed, 25 to 50 miles per hour, and high speed, more than 50 miles per hour. And within each speed category, there are different STP categories. And as STP goes up, the fuel consumption also goes up. So what we did is that we basically decided to eliminate operations that fall under these red columns. And we kept and we moved these operations to the black columns. The resulting speed time trace would then look like this. As you can see, the blue is the observed original duty cycles, and the red are the eco-driving cycles. And you will notice that all the hard accelerations on the screen that I'm highlighting have been trimmed. And but we also have a control so that the travel time doesn't increase too much to affect the schedule. So here, let's look at the case study. The data we used are second-by-second transit operations data. We logged on the 2 agencies' buses. For local transit, we looked at the Metropolitan Atlanta Rapid Transit Authority. And for express bus service, we looked at the Georgia Regional Transportation Authority, GRTA. We also pulled together GIS files, fleet composition from the National Transit Database, and operating schedules from the General Transit feed specification. This is an overview of the MARTA operations. As you see on the map right here, MARTA's operations are mostly inside the urban core. This is our beltway in Atlanta, I-285, and most of MARTA's operations are inside the beltway. And MARTA has 158 diesel buses and 350 CNG buses. We used 15 GPS loggers, and we logged a significant amount of MARTA real-time, real-world operations, more than 65,000 miles and more than 6,000 hours. For GRTA, this is an overview of GRTA's operations, and you'll notice that GRTA's service, since it's our express commuter service, its service goes way beyond the I-285 beltway, and most of its operations are on the freeways. GRTA has 166 diesel buses. We used 14 GPS loggers. We logged quite a bit less than what we did with MARTA, but still a significant amount, close to 6,000 miles and more than 100 hours. So these data samples give us a realistic understanding of what the transit operations look like. This slide gives us an overview of the method. It's a fairly busy slide, I understand, but the point here is that here on the left, the whole part basically talks about the multiple steps we did to clean the data to make sure that the GPS data are correctly filtered and cleansed before we conducted our fuel and emissions calculation. And on calculation, and on the right, it basically shows that we took two parallel routes to compare the observed cycles and the eco cycles. We used the EPA's MOVES model for on-road emissions. We also used the Oregon National Labs GREET model to assess the fuel cycle emissions to produce a fair comparison of fuel and emissions. We tested three scenarios. Eco-driving, of course, is our focus of this study, but we also understand that CNG is a popular choice amongst a lot of transit agencies, so we wanted to also look at the fuel and emission savings provided by converting to a new CNG fleet. And then we combined the two strategies to look at how much further savings eco-driving could provide for a CNG fleet. Now, here comes our results. The first one is about fuel consumption, and I have presented fuel consumption in terms of fuel economy. And on the left is local transit as represented by MARTA, and on the right is the express service as represented by GRTA. So I do want to point out before I move forward that the base fuel consumption, you'll probably notice the base fuel consumption seems a little bit higher than an agency would actually see from based on their fuel receipts. And that goes back to my earlier point that this study is only looking at really on-road operations. We did not include any of the idling that might occur at garages and at stations. So the fuel consumption from idling is not included in this analysis. All right. So what are we seeing here on this chart? The first one is that you will notice eco-driving improves fuel consumption, and this is true for both MARTA and GRTA. So you notice here that eco-driving improves fuel economy for express service here too. And the second point is that due to the engine characteristics for CNG actually decreases the fuel economy by just a little bit. However, if you apply eco-driving techniques to a CNG fleet, you'll notice that the eco-driving plus CNG scenario improves the fuel economy for a CNG fleet as well. Now, what does this mean for life cycle greenhouse gas results? Here, this chart shows us the greenhouse gas emissions for the entire fuel cycle. Now, what do I mean by the entire fuel cycle? We look at pump-to-wheel as well as well-to-pump emissions to account for the emissions that occur beyond the tailpipe. So the pump-to-wheel portion is also referred to as tailpipe or on-road emissions. The EPA's MOVE model estimates pump-to-wheel emissions. The well-to-pump emissions refer to the emissions related to the extraction, processing, storage, and delivery of the fuel. And we obtained the well-to-pump emissions results from the Oregon National Lab's GREET model. Now, from the perspective of life cycle greenhouse gases, eco-driving again appears advantageous compared to the base case. For example, for the MARTA fleet, greenhouse gas emissions over the entire fuel cycle decreased from 3.2 kilograms per mile to 3 kilograms per mile. A CNG fleet also provides some reduction in fuel cycle greenhouse gas emissions compared to the base case, but not as much as eco-driving. And again, eco-driving further reduces the greenhouse gas emissions for a CNG fleet. And we see that again for both the local transit and the express service. Now we move on to air pollutants. NOx is one of the important pollutants to consider for heavy-duty vehicles such as transit buses. On this slide, we can see that eco-driving provides a slight reduction in NOx emissions. Now, however, converting to a CNG fleet will show a much more pronounced reduction in NOx, given the fuel properties of CNG. You will notice, though, on this slide, that it appears that CNG reduces NOx emissions by a larger percentage in express services as compared to in local services. Two factors come into play here. First, CNG engines perform a little bit better in high-speed operations. Second, and more relevant to this case, since MARTA already has 350 CNG buses, if you recall from the overview of MARTA operations, this case study scenario only converted a third of its fleet to new CNG buses, whereas for GRTA, we converted its entire fleet to CNG buses. And this slide shows the PM 2.5 emission rate results. And PM 2.5, or fine particulate matter, is another important air pollutant. Similar to the comparison made for NOx, when it comes to PM 2.5, a CNG fleet would dramatically decrease emissions. Nevertheless, we still see that eco-driving showed noticeable reduction compared to the base case. Now, we've looked at the fuel and emission savings so far. But what does it mean to an agency's bottom line? This slide shows the cost savings for the case studies we looked at. For MARTA buses, for the MARTA fleet, which has up to 508 buses, the fuel consumption reduction was 5%, and that amounts to 300,000 gallons of diesel fuel equivalent per year. Even with today's low diesel fuel price, and we assumed $2.4 per gallon, we're looking at $720,000 in annual fuel savings, or $1,000 per bus per year. For Greta's 166 buses, the fuel consumption reduction was 7%, which amounts to 55,000 gallons of diesel fuel per year. It also translates to $132,000 in annual fuel savings, or $800 per bus per year. And the lesser amount mostly is associated with the fact that Greta buses generally log less mileage than the typical MARTA bus. So far we've talked about savings, but how much does it cost to implement eco-driving? Luckily, Georgia Tech, our team has had ample experience in implementing fleet monitoring, and we assume that to effectively implement eco-driving training is not enough. You actually have to monitor the drivers and give them real-time feedback. It has been shown in previous research that that's a lot more effective strategy. And we did some preliminary estimates. It costs about $650 per bus per year to implement the whole monitoring scheme for eco-driving. And this includes equipment, communications, driver training and incentives, and data analysis. Here, we come to our conclusion. As I previewed at the beginning of the presentation, excuse me, without significant capital investment, eco-driving can reduce fuel consumption and emissions, will provide net cost savings, and is also effective for CNG fleet. Now, if we implement eco-driving with monitoring, we are also looking at ancillary benefits. That includes asset management, because now you're tracking your buses, on-time performance evaluation, and driver safety assessment. So what are we doing now to take eco-driving to the real world? Georgia Tech is right now working with MARTA to conduct a demonstration project. The way we do it is to use our Commute Warrior smartphone app. As you'll see on the right, that this is an interface, and of course for bus drivers, we're going to take out all the settings and journal buttons so that there is no driver interaction. But you'll see the green dot on top, that is showing the current operating mode. If you're in the green zone, that means you're in the low fuel and emissions category. Yellow for medium fuel and emissions, red for high fuel and emissions. And the concept is pretty straightforward. If you're in the yellow or red zone, you would simply take your foot off the gas pedal a little bit. And I think most of us have experienced this with our light-duty vehicles, with the cars that we drive. A lot of times we already have the eco-driving mode. A little light would turn on in our cars to indicate that we're driving in eco mode. So with that, I conclude my presentation, and I'll take comments and questions. Thank you.
Great.
Thank you very much.
Great. Thank you so much, Ann. And we could all hear you grappling with your cough there. So thanks for sticking to it and trying to get through the presentation. This is Laura Podolsky again at the National Center for Sustainable Transportation, and I would like to first turn it over to our guest respondents today to get their initial reaction to their research and thoughts on eco-driving for transit in general. So Rob Goodwin, if I could turn it to you first, that would be great.
Sure. Thank you, Laura. And first of all, Ann, great job on the presentation. I can sympathize with you. It was about almost 90 degrees here in Atlanta a couple days ago, and today it's struggling to get to 60 degrees, so I feel for you. Anyway, by way of a brief introduction, the Georgia Regional Transportation Authority operates the Express Commuter Coach Service in Metro Atlanta. Consists of 33 express bus routes operating from 30 park and ride lots in 12 counties. We carry more than 2 million passengers annually, connecting workers with several of Atlanta's major employment centers. So like most, if not all transit agencies, GRTA's express operating budget is very constrained. Unlike many, or if not most, transit agencies, GRTA does not have a dedicated funding source. Instead, we rely on annual appropriations from the Georgia General Assembly to fund up to half of the operating costs of Express. And so having to compete with so many other state priorities for limited funding each year really places a premium on running a lean and efficient service for us. And so the idea of eco-driving helps with that. Up until this year diesel prices have dropped to something like a 7-year low. But up until this year, fuel's made up more than 20% of our Express annual operating budget. So any opportunity to reduce fuel costs by operating more efficiently would really help us to make our case to the General Assembly and would help reduce the amount that we have to ask for in appropriations. That's a real plus. And based on the findings in this report, we could reduce our annual operating costs anywhere from $150,000 to $300,000 based on fuel prices. And as Ann pointed out at the end, there's other ancillary benefits, including reduced wear and tear on the buses, reduced insurance claims through safer driving, and not to mention that Atlanta is a non-attainment area for both ozone and particulate matter, so it would help from that perspective as well. So my main, I think, suggestion, thoughts on this, I think what would really help for future direction in this research would be really focusing more on quantifying the operating costs of implementing this kind of a program, in addition to the benefits, and also how those. So there's some current technologies out there. Some of this is being done, although the focus is not on emissions, to my knowledge. It's more on saving fuel and managing risk. For example, one of our contractors that is going to operate a big chunk of our service starting next fiscal year is proposing to use a tool that will monitor the driving behavior of our operators and help to coach them on less aggressive driving. It's mostly to manage risk in that case, but it also would presumably reduce fuel consumption and emissions as well. It's really key that the costs of implementing an eco-driving program are ideally they're a lot less than the benefits, but when it starts to get close, that's where I imagine transit agencies would wonder whether it's worth the cost. Ann, you mentioned that I think the number towards the end was maybe $130,000 a year to implement this program. and that's getting close to roughly the benefit, depending on the price of fuel that we might achieve, and that's where kind of refining those costs and the benefits might help to make a stronger case for this. And we also, another aside, we also already implement idle controls on our buses. They're supposed to idle no more than 5 minutes before the engine shuts off automatically. So that helps save fuel and emissions. And we also have governors on our engines to limit the highway speeds of our buses, which also saves fuel. So there's technologies already out there, but this could definitely help complement or supplement those technologies. So I'm very interested in hearing more about it and seeing where this research goes in the future.
Thank you so much, Rob. And now if I could turn it over to Art Gazzetti for his thoughts and reaction.
Hey, thank you, Laura. And APTA, of course, with all the nation's transit systems and communities, large and small, I wanted to thank and compliment UC Davis, Georgia Tech, and the National Center for Sustainable Transportation. A great product to be moving forward. APTA promotes transit as a sustainable strategy overall for communities. The more transit a region has, the more sustainable the region will be. But at the same time, transit systems certainly can adopt various practices to allow ourselves to operate in the most energy efficient way. Just one small note, for example, 20 years ago, about 2% of the nation's transit bus fleet was powered by alternate fuels. Today, the number is 46%, and it's going up and up and up. Compare that to the auto fleet, and you'll see we really have a huge commitment to sustainable transit operations. Add that to this smart cities emphasis, where on emphasis on data and technology to inform decision making and to measure performance. The percentage gains that your report shows, 5% for local bus service, 7% for express bus service, those are very significant. We can certainly look at those as huge steps forward and ways to embrace. The research speaks for itself. What excites me is the messages that we can take forward from this. APTA certainly has a network with all the transit systems, and I definitely want as a next step here to talk about ways we can take this research to those networks. I'll pause, and I think we'll have a discussion continuing from here.
Great. Thank you so much, Art and Rob, for those opening comments. So we do have a question coming in from our participants. One of our participants would like to know, has there been any studies on the effects of safety for eco-driving? It seems like it would allow for a smoother and safer ride, but it would be good to know if there was data to back up safety. So I would assume, Anne, maybe you could take a first stab at this, but Rob and Art, if you're aware of any of those studies too, please chime in.
Yes, absolutely. We actually have in our group looked at the safety impacts. That was actually from a few years ago from monitored instrumented vehicle fleet, and the insurance industry is very interested in fleet monitoring because based on our analysis, the crash behavior is very much correlated with aggressive driving. That's also key in the eco-driving.
Great. And then Art and Rob, did you have anything to add to that? I'm not sure if you're aware of studies around the safety aspects of eco-driving.
Safety is huge, so let me just say I don't know of any studies on eco-driving particularly, but safety is such a huge issue. If there are, any safety aspect of it would be central.
All right, fabulous. So we don't have any other questions that are coming in, so if any of you are listening out there, do please type your question into that chat box, and we would love to ask those to Anne and Art and or Rob as we have them on the line. I do have a question for you, Art, in knowing that the transit fleet is, embracing and becoming, using more alternative fuels or alternative drivetrains. Where do you see this really future of eco-driving taking off, as in relevant, and related to the other priorities that transit agencies are facing?
Well, one interesting thing is it's been about the technology itself of clean buses. This sort of says, hey, there's things we can do as practices on top of that. Now, some of this is technology. You have that red, green, and yellow, lights to inform the driver how they're doing. But a lot of the stuff is, maintaining a steady speed, limiting high speed, avoid accelerations, anticipating the traffic. All of the particular things are all sort of behavior. So these are on top of the technology improvements we can make. So it's definitely additive.
Great. We do have another question coming in. This question is regarding, are there any resources that could be sent to our local transit agencies related to implementing eco-driving? I'm not sure, Ann or Rob or Art, whose question that this would be best addressed to.
Yeah. Well, as I mentioned in the slides, we're currently doing a demonstration project, and hopefully a few months from now, we'll have some publications on how exactly we implemented the strategy. As Rob mentioned earlier, that I think everybody is eager to know how the details work out and how it feels and then works in the real world, and we are looking forward to sharing our results a few months from now.
A question I'd like to throw out here is there been any reaction from a driver point of view? Does the driver think these things would be, would they be feasible from a driver perspective? Bus operators.
Well, again, we'll find out once we start the demo project with MARTA. Yeah, we'll definitely keep an eye out on that one.
And we do have another question that just came in. This question is for Rob. So does GRTA use diesel or CNG buses? And it was mentioned that a slide showed much lower NOx and PM emissions for CNG, so I'm wondering if GRTA has considered converting to CNG if they don't already have a CNG as a part of their fleet.
So currently our fleet is all diesel coaches. We had 9 CNG buses up until last year. It was a bit of a challenge, at least those vintage buses were not as well suited for our business model as the diesel coaches. A typical route one-way trip is about 25 miles, and it just didn't really fit in with our business model. It's certainly something we would consider going forward, but currently we are 100% diesel.
And if I may add to Rob, that converting to a CNG fleet does come with a significant capital investment. Not only are CNG buses a lot more, cost a lot more, but you also have to consider constructing and operating the fueling facility, and I think that's what Rob alluded to. So that's one of the things that one of the reasons why we were so interested in the eco-driving case is that eco-driving does not require that significant amount of upfront investment.
Great, thank you. And this is a question to Ann and both of our guest respondents. Is curious to know, is there anyone out front on this, any transit agencies that you either or all of you are aware of that are implementing eco-driving as a part of their operations? Is there a leader in the field? Or is this a new area that we're slowly stepping into?
I think that eco-driving is not a new concept, but the technology that helps to actually effectively implementing it is just now catching up. So we're hoping to see more and more of it.
The only thing I could say, Art Gazzetti from APTA here, is that there are best practices in a whole number of places. Of course, the buildings, the LEED, the LEED standards are now in wide practice and gaining. The maintenance practices at facilities. There are so many ways people can adopt sustainability practices. And I think the eco-driving, the concepts have been around, but I see this as a way to sort of burn it in a little deeper and make it a, here's the checklist, here's the quantitative proof that it's effective from an energy efficiency point of view and emissions. And thus, this is part of the answer. So APTA, in response to a question earlier about how can we take these messages to the transit industry, one way, among many, is there's a sustainability conference that APTA has every year, and the true leaders of the industry in that sustainability field are all there. And I think this new research is a way to get them excited more about this practice of eco-driving. We'll be definitely following up to showcase this at that meeting.
Great, fabulous. Thank you, Art. So with that, I don't know if Rob or Art, you have any additional questions. Oh, we actually do have one more that's popped in, so maybe we'll ask this one from our audience. Eco-driving, so this is actually pertains to California policy that we have here, but the question is about eco-driving is not included in SB 375 as a method to reduce greenhouse gas emissions. And for those from outside of California, SB 375 was a law passed in 2008 that directed metropolitan planning organizations to create land use plans as a part of their regional transportation plans, called, and this new name is Sustainable Community Strategy. So it is a regional land use and transportation plan with the goal of reducing vehicle miles traveled and thus greenhouse gas emissions. So eco-driving is not included in SB 375 as a method to reduce greenhouse gas emissions. Is there any discussion about implementing it under SB 375? And I don't know if I'm not aware of that. I think I'm the only California person here, so I can't speak to that. Though I do see some of our participants on the line today, from the Air Resources Board here in California, and they might have a better idea. So we might have to follow up on this email offline, unless it just so happens that Art, Rob, and Ann know about California policy and how it's being implemented.
Oh, such luck.
Art here. I can't speak to. I'm sorry, Rob. I'll let you in, but I can't speak to SB 375. But it is a best practice, right? I don't know if you can mandate this, but and especially since there are considerations such as safety, such as overall cost efficiency, and also operations. I hope the test study shows that transit is a very stop and go type of business, the urban buses. So all of those things also, in addition to the energy efficiency aspect, have to be considered. So I don't think it should be mandated, but I think it should be a best practice.
Great. Thank you so much for chiming in, Art. So I don't see any other questions coming in from our audience. So, I was interested in if we have time, if Art or Rob, if you want to comment, how are these numbers and the research that Georgia Tech has done here, has it shaped or changed your thinking about eco-driving? I know you've already commented on that, but I was just curious if any of those numbers that they came up with around the reductions in fuel or the certain emissions or the fuel and savings, did anything jump out to you and catch your attention initially with this study?
Well, I'll go ahead and just reiterate, they are significant numbers from my perspective in terms of our operating potentially significant in terms of our operating budget and helping us make our case of running as efficiently as possible. But again, the key is having a better grasp on the cost of implementing it, and how, if it's a clear winner in terms of the benefits versus the costs, why wouldn't we do it? So, as I said, I'm excited to see where the research leads.
And Art Gazzetti here. What I'd like to underscore is that transit fashions itself and is legitimately a sustainability strategy for regions to embrace. But if regions are going to embrace it, we have to do whatever we can to make ourselves as sustainable as we can be. And so this is a way to take a strategy, transit, that's already a very effective sustainability strategy for regions, and make that strategy even more attractive to regions. So that's what I like about it, and among other things.
Fabulous. Thank you so much. So with that, Anne, is there any closing comments that you would like to make, discussing some of your upcoming research? I know you'll be reworking with Marta. I don't know, did you mention when that research will be wrapped up, and when do you think you'll have results to share?
I don't have a clear picture yet. We've met with Marta, and they're very interested, so we're working out the details, so hopefully soon. But in the meantime, while we wait on actually putting it in the field, we are currently under contract with the Department of Energy to look at how eco-driving can reduce fuel consumption on the regional level for all vehicle types, mostly passenger cars. And it's also implemented through the smartphone app. And that project is a $3 million three-year project. So along the way, we'll be sharing results with everyone. So, I would like to say that eco-driving, even though right here we reported mostly on transit buses, it is a very effective strategy for all vehicle types as well. And we have been doing lots of research in this area, and we'll continue this research.
Fabulous. Great. Well, we'll all stay tuned and make sure that we're getting that information out to everyone. So I'll, in the follow-up email, include links to Georgia Tech's homepage and website where you can go to read more about the work that they're doing around eco-driving. There'll also be links to our page at the National Center for Sustainable Transportation where you can read more about Georgia Tech's work. We also have white papers from our researchers here at UC Davis that are also looking at that eco-driving for passenger vehicles. And we did have a webinar last year featuring Ken Karani and a new white paper that he put out summarizing the research on eco-driving for passenger vehicles. So I can include some links for our other eco-driving research as well. So before we close out today, I just do want again to thank our speakers and our special guest respondents for participating today. It means a lot for us to hold these webinars, make sure that the research that we're doing is actually getting out there, and that policymakers and practitioners understand it and can put it into practice. So we're really thankful for, again, our speaker, Anne, today, and our special guest respondents, Art Gazzetti and Rob Goodwin, and everyone who's on the call today that took the time to participate. I do just want to call your attention to look for your inbox for a follow-up email that will be going out. Will include links to everything I mentioned today, and very specifically a link to our survey. And we'll put that link in our chat box right now, so you can take the survey right now. And that survey, one of the questions is to tell us what you feel the future directions are for this research, and that will be very helpful in thinking about the type of research that the National Center for Sustainable Transportation will fund on this topic. I do also would like to tell everyone to mark their calendars for 2 upcoming webinars that we also have scheduled. We have one coming up on May 19th, which is a large departure from what we're talking about today, but this is actually focused on wildlife populations and transportation and some of the interactions that occur with wildlife movement and highways. So the name of that webinar is Do Highways Act as Barriers to Gene Flow for Wildlife Populations? And so I can send, again, this information out in our follow-up email. Our next webinar will be June 1st, and this one is entitled Intelligent Transportation System Solutions that Reduce Fuel Use and Emissions. It's featuring a presentation from our partner at UC Riverside, Matt Barth, who will share findings from his latest white paper examining the state of the practice for ITS approaches that reduce fuel and emissions. And we have 2 great special guest speakers for that as well, Marco Anderson from the Southern California Association of Governments, and Samir Rahab, who is the ITS research engineer at Honda Americas. So with that, it looks like we will be ending a little bit earlier today, and everyone gets 5 more minutes back to their day. So thank you again for attending, and again, we'll be sending that follow-up email. Thank you so much. This concludes our webinar for today.